Okay, today's notes are going to be on vector patterns. For each, plot the given points, then sketch and describe each vector using components. So here's our 3 points, and so let's plot those. From the origin, we're going to move 3 to the left and 1 down for point A. And label your points. For B, from the origin, we're going to move 2 to the left and 2 up. And for point C, we're going to be moving 3 to the right and 4 up. All right, so when we're looking at vectors, the order is important. The first letter represents the tail, the second letter represents the tip. This is the direction that the vector is moving. So this first vector, we're going to start at A and move towards B. Make sure you put the arrow at the tip, otherwise you're not drawing a vector. Remember, vectors have length and direction. All right, vector BC starts with B, moves towards C, and then we have vector AC. Okay, so let's find out what the components are. Components use these little triangular shape pieces. It looks like a less than sign and a greater than sign. I forgot to mention that yesterday. Make sure you are not using parentheses when you're referring to a vector. Parentheses are going to be for points. Okay, so on a vector, your first component is the horizontal. And if that number is positive, you're moving to the right. If it's negative, you're moving to the left. And the second component represents your vertical. And if that guy is positive, you're moving up. Negative, you're moving down. So for vector AB, we're starting at A, moving towards B. The horizontal component would be 1 unit to the right, so we know that's a positive 1. And 3 units up, so we know that's a positive 3. So this guy is just going to be 1, 3. Okay, for BC, again, start at the tail. We're moving 1, 2, 3, 4, 5 units to the right and 2 units up. And the last AC, again, start at the tail to the tip. We're moving 1, 2, 3, 4, 5, 6 units to the right and 5 units up. Okay, so the method that I used on these vectors was just simply counting the horizontal and the vertical components. Sometimes your vectors are very large. Yesterday's notes, there was a formula, and I'm going to show you how to use that formula on this next problem. To find the horizontal component, you're going to take the second x and you're going to subtract the first x. That will give you your horizontal component. And then you'll take the second y and you'll minus the first y. That'll give you your vertical component. And so if your vectors are using very large numbers, you might want to use this instead of just my counting method that I used on the first example. Okay, so let's plot these points and then we'll use this to figure out the components. Okay, so negative 3, 4, negative 1, 1, and 4, 1. Take a minute, draw your vectors, and try to identify your components. All right, so there are my vectors. Okay, and so if I want to use the method where I'm subtracting the horizontal and vertical components, I want to go ahead and label my points with their values, with their x and y values. Okay, again, we're using parentheses for coordinates, the little triangle shapes for the vectors. Okay, so my first vector is A to B. So if I want, which I would suggest you do, this is my first x, my first y, my second x, my second y. All right, so to find the components, I would take my second x, which is -1, subtract my first x, which is -3. So this is -1 minus a -3. Little scratch work here. -1 minus a -3. Double negative makes that plus. And -1 plus 3 is 2. That means my horizontal component, I'm moving 2 to the right. Okay, let's do the same thing with the y's. I'm going to take my second y. This time I have 1 minus my first y, which is 4. And so 1 minus 4, and that is -3. So my vertical component says move down 3. Okay, let's just verify that. From A to B, I'm going 2 to the right, a +2, and 3 down. All right, let's work the next vector from B to C. So I'm going to erase my x1, y1. This time my x1, y1 is the B coordinates, and my x2, y2 are the C coordinates. Okay, so let's do a little scratch work. X2 minus x1, so I've got 4 minus a -1, and so that's double negative, so that makes that plus, so that's going to be 5. And then y2 minus y1, I have 1 minus 1. Well, 1 minus 1 is just 0. And so the components for this vector are 5, 0, which say that you're moving to the right 5 and you're moving vertically 0. So let's just verify that. From B to C, you're moving to the right 5 and you're not moving up, so that looks good. And then my last vector, I'm going to go ahead and erase these again and label them. Okay, so I'm going from A to C. And so my x1, y1 are the A, and my x2, y2 are my C. And let's go ahead and do my little scratch work. So x2, which is 4, minus x1, which is -3. A double negative makes that plus, and so that's 7. And my y2, which is 1, minus my y1, which is 4. And so 1 minus 4 is -3. And so my components for this guy are 7, -3. And let's just verify that. Starting from this tail to this tip, I'm moving to the right 1, 2, 3, 4, 5, 6, 7, a +7, and I'm moving down 3. So that looks good. Okay, so I'll let you choose which method you want for this last example. Go ahead, plot your points, draw your vectors, and see if you can come up with your components. Okay, so here are my vectors. Since I'm working on this little coordinate plane, I think it's easiest to just count. And especially for this problem, you've got a vector that has no horizontal components and a vector that has no vertical components. So this one's a pretty easy set of vectors to solve. So for this first vector, from A to B, I said our horizontal component, there is none. So that's just 0. And you're moving 1, 2, 3, 4 units up. So that's going to be 0 with a +4. From B to C, you're moving to the left 1, 2, 3, 4, 5, 6, 7, 8. And so that's just going to be -8 with 0 vertical component. And your last vector from A to C, you're moving 1, 2, 3, 4, 5, 6, 7, 8 to the left. 1, 2, 3, 4 up, and so 8 to the left and 4 up. And that's it for today.